So we're supposed to find this integral. That means we need the antiderivative. You can factor out that 9 if you want, but it really doesn't bother me. I'm going to keep it here. This is the same thing, just rewritten in a different form. If you have x in the denominator, you can move it into the numerator. The exponent just needs to change to be a negative. And that is just the power rule in reverse. When you take a derivative, usually the power goes down. When you take an antiderivative, the power goes up. So this is 9x to the negative second. The power went up by 1. But hold on, before we're done, if you were to take a derivative of an antiderivative, it needs to be the original function. If the negative 2 comes down and multiplies, then it gets reduced by 1. We get negative 3 here, but the coefficient is wrong. That'd be negative 18. So we got to balance that by dividing by negative 2. Now if you take a derivative, negative 2 comes down, cancels out with the negative 2 on the bottom, so we're left with 9 like we want. Then the power reduces by 1. So that's our antiderivative. And now it's just plugging in numbers. You could actually, before you do that, this might help with plugging in numbers. You can rewrite this back in terms of a positive exponent by moving that downstairs. We just made it a negative exponent to help us evaluate the antiderivative. Evaluate the antiderivative, I guess. So we plug in negative 2. Negative 2 is getting squared, so that's 4. 4 times negative 2 is negative 8. So we'll put the negative sign up top. And then that's the upper limit of integration. Now we plug in the